Welcome everyone. Today I will discuss some amazing problems of inverse circular function. You know, inverse circular function is the most important chapter. You must get one problem in each competitive exam. In West Bengal Joint, in JEE Main, JEE Advanced, or each competitive exam, as well as boards also. Today I will discuss problems of inverse circular function, and it is mixing with concept of other topics. So these are all problems of JEE Main. So look, let x star y equals to x square plus y cube. So x star y, so this is concept of binary operation. First term whole square plus second term cube, and x star 1 equals to x star 1 plus 1. That is, star satisfies here associative laws. Then you have to find value of two sign inverse, x to the power 4 plus x square minus 2 by x to the power 4 plus x square plus 2. Now you know sign inverse. So this is argument. So you have to simplify the argument by using the given relation in terms of binary operation. Now look, x star 1, x star 1 plus 1 star 1. So that is star satisfies associative laws. Now what is x star? X star 1. So this implies x square plus 1 cube by this rule. First term whole square plus second term cube. Now this is unchanged. X star, so 1 plus 1 square plus 1 cube. So by this heavy rule. Now simplify. X square plus 1 star 1. So x star 2, 1 square plus 1 cube. Now again apply the rule. What is x star y? So first term whole square plus second term whole cube. So this is coming with the help of this operation, and this is x square plus 2 cube. Now simplifying, we are getting x to the power 4 plus 2x square plus 1, and this is x square plus 8. So x to the power 4 plus x square. So this is 1 plus 1, I think it is 2. So here we are getting 1, and this is, so x4 plus x square equals to 6. So we are getting this equation, simplifying this binary operations. Now it is very simple. So 2 sign inverse, x to the power 4 plus x square minus 2, x to the power 4 plus x square plus 2. So 2 sign inverse. Put value of x to the power 4 plus x square. This is 6 minus 2 by 6 plus 2. So 2 sign inverse. This is 4 by 8, that is half. So 2 into 5 by 6. Sign inverse half, this is 5 by 6. So we are getting final result as 5 by 3. So what is our final result? This is 5 by 3. So look, this is very simple problem but most interesting. So argument is this one using idea of, so this one is given binary relation. So simplify this part and do that later. So this is problem of JEE 2020. JEE 2020. So apparently this looks difficult, but if you simplify it, it is very, very simple problem. Next, now we consider one more problem. Fx equals to 2 cos inverse x plus 4 cot inverse x minus 3x square minus 2x plus 10. If AB with a range of fx in minus 1 to plus 1, then 4a minus b equals 11, 11 minus pi, 11 plus pi, 50 minus pi. So this is also mixed problem. So fx is this one, 2 cos inverse x, 4 cot inverse x minus 3x square minus 2x plus 1. Now you have to find a range of fx in minus 1 to plus 1. So here fx, this is also mixture of algebraic and trigonometric function. So it is difficult to find the range. But if you look the characteristics of fx, so you find, so whether it is increasing function or decreasing function. So f dash x equals to derivative of cos inverse x is negative minus 1 by 1 minus x square root over. So cot inverse x. So this is 400, 1 by 1 plus x square with negative. This is minus 6x. This is 2. Now each term is negative. Each term is negative. So f dash x less than 0 in minus 1 comma 1. So fx is decreasing function. Decreasing function. Fx is decreasing function. So look, if fx is decreasing function, so suppose this is minus 1 and this is plus 1. So if it is decreasing function, so look, figure will be of this type in minus 1 to plus 1. So if it is decreasing function, you look, f1 is minimum and f of minus 1 is maximum. Now if it is increasing, so look of this type. So at this point this is minimum, at this point it is maximum. So here fx is decreasing function. So what is f of minus 1? F of minus 1 will be maximum value. Will be maximum value equals to f of maximum. Now if we put this minus, so 2 cos inverse minus 1, 4 cot inverse minus 1, minus 3 into minus 1 whole square, 2 into minus 1 plus 10. So what we are getting? Cos inverse minus 1. So 2, so cos inverse minus 1, this is pi. Cos pi is minus 1. And 4 cot inverse. So 4, this is pi minus cot inverse 1. You can also write this as pi minus cos inverse 1, no harm. So this is minus 3 and this is 10 plus 2, 12. 12 minus 3. So this is plus 9. So finally 2 pi plus 4 into pi minus pi by 4 plus 9. So 10 pi, 4 pi plus 2 pi, 6 pi minus pi. So 5 pi plus 9. So this is maximum value. So maximum value AB. So this one is B. So what is our B? B is 5 pi plus 9. So this should be noted. So look at the characteristics of the function. So if you take f dash x, all terms will be negative. So it is decreasing function in the said interval. So f of minus 1, we are getting 5 pi plus 9 and this is B because it is maximum. So you can find, now you can find what is f of 1. F of 1 equals to 2 cos inverse 1, 4 cot inverse 1, 3 minus 2 plus 10. 3 minus 2 plus 10. So we are getting 2 into 0. 4 into pi by 4, 10 minus 5. So this is plus 5. So 5 plus 5. And this is equal to minimum value. And this is 8. So 5 plus 5, we are getting, this is A and this one is B. Now you are getting A and B. So calculate 4A minus B. Now 4A minus B equals to 4 into, what is A? 5 plus 5 minus, what is B? B is 5 pi plus 9. So 20 minus 9, so 11 minus 5. 11 minus 5, so this is option B. Now look, AB is the range. Now look, A is minimum value, B is maximum value. So A is minimum, B is maximum because it is decreasing. So this should be noted. So simplifying, we are getting 11 minus 5. So this is also very typical problem. So most interesting also. This is problem of JEE Main 2022. Now we consider one more problem of JEE Main. So look, sin inverse x whole square minus cos inverse x whole square equals to A. Then 2x square minus 1 equals cos 4a by 11 sin 2a by 11 cos 2a by 11 sin 4a by 11. Here a not equals to 0 and x lies between minus 1 to plus 1. So look, A equals to sin inverse x whole square minus cos inverse x whole square. So you factorize it. Sin inverse x. So sin inverse x minus cos inverse x. Now, so listen again. To solve problems of competitive exam, you must know the basic concept. So basic problems of inverse circular function. I have already completed 7 classes regarding this chapter. So you must know the basic concept. So look, sin inverse x plus cos inverse x, this equals to pi by 2. Now, and when x belongs to minus 1 to plus 1. So x belongs to 0 to 1. So that is in this restriction. So we can put it as pi by 2. And sin inverse x, this is equation. So you write it in terms of same inverse circular function. So this one. So we are getting, this is sin inverse x, sin inverse x. So 2a by pi. So 2a transfer here pi. So 2 sin inverse x. 2 sin inverse x minus pi by 2. Minus pi by 2. So divide throughout by 2, we are getting sin inverse x equals to a by pi minus pi by 4. So sin inverse x divide by 2, this is sin inverse x, this will be pi by 4 transferred to right hand side. So this will be obviously pi by 4 and this is a by pi. So what is x? X equals to sin pi by 4 plus a by pi. So this is value of x. Now you have to find 2x square minus 1. Now 2x square minus 1. So 2 into sin square pi by 4 plus a by pi minus 1. Now we know cos 2 theta equals to 1 minus 2 sin square theta. Now it is, if we take minus common, so 1 minus 2 sin square theta, so this is cos 2 theta. So cos 2 into pi by 4 plus a by 2. So by this very formula, we are getting this one. Now minus cos I by 2 plus 2a by pi. Now use trigonometry, cos 90 plus theta minus sin theta. So minus minus cancel. So sin 2a by pi. So sin 2a by pi. So 2x square minus 1 equals, so this will be 4a by pi, not 11, sin 2a by pi, cos 2a by pi, and this is sin 4a by pi. So what is our correct option? So 2a by pi. So this is also simple problem but given in two-step form. So most interesting problem, amazing problems. So very simple relation, use well-known result, and this step to be noted. Dx, so put value of 2x square minus 1. Value of x, use trigonometry and you get result. Now we consider one more problem. This is also mixed problem of inverse circular function and logarithmic series. To solve this problem, you should know the log series. So try to recall log 1 plus x. So this is x minus x square by 2, x cubed by 3 minus x to the power 4 by 4 dot dot infinity. So this is our relation. So log 1 plus x, the sum of the series x minus x square by 2 plus x cube by 3 minus x4 by 4 dot dot infinity. When x lies between minus 1 to 1, minus 1 not included here, is equal to log 1 plus x. So this is our working proof. Now look, given condition is tan inverse A plus tan inverse B. Very simple relation. This is pi by 4. Pi by 4. And A and B are positive, lying between 0 to 1. So this implies tan inverse A plus B by 1 minus AB equals to tan pi by 4. Equals to pi by 4. So formula of tan inverse A plus tan inverse. Now this is A plus B by 1 minus AB equals to tan pi by 4. This equals to 1. So we are getting A plus B equals to 1 minus A. That is A plus B plus AB equals to 1. So from given relation, we are getting A plus B plus AB equals to 1. So only this concept of inverse circular function. Now you look the series. This is infinite series. So A plus B, A square plus B square by 2. So A plus B. This is A square plus B square by 2. So this one is minus. Then alternatively plus and minus. A4 plus B4 by 4 dot dot infinity. Now look, we want to put this series in terms of well-known series. Look, if we take first term within one bracket, first terms, so A cube by 3 minus A4 by 4. And second term within one bracket, B minus B square by 2 plus B cube by 3 minus B to the power 4 dot dot infinity. Now look, this is well-known formula. This is log 1 plus A and this one is log 1 plus B. Now sum of log is product of log. So log of 1 plus A, 1 plus B. So what we are getting? Log 1 plus A plus B plus AB. Now log, so this one is from relation 1, so this is 1 also, 1 plus 1. So log 2. So 1 and change and this is 1. So log 1 plus 1. Obviously base is 2. In mathematics, if base is not given, we suppose base is e. So we are getting option as log 2 base e. So most simple problem, but you need idea of log series. So these are mixture problems. Next. Now one more problem. Number of solution of the equation tan inverse x into x plus 1 sin inverse x square plus x plus 1 equals to pi by 4. Number of solutions. NO means number. 4 solutions, 2 solutions, 0 solution, 1 solutions. Now it is trigonometric equation. Now we solve this problem using domain. Now this one is tan inverse x. So So domain of tan inverse x df equals to minus infinity to infinity. But look, argument is given within root over. So if it is given within root over sign, we know. So negative part is cancelled out. So df is 0 to infinity. df is 0 to infinity. We can take 0 also. Now, domain of sine inverse x. So df, what is df? Minus 1 to plus 1. This is domain of sine inverse x. Now here also it is given, argument is written within the program. So negative part is absent. So if it is within the program, negative part is cancelled out. So we use this idea. Now tan inverse x into x plus 1. So what is domain of f? X into x plus 1 greater than equals to 0. So we are getting x into x plus 1 greater than equals to 0. And look, this is domain x square plus x plus 1. So this lies between 0 to 1. Now x square plus x plus 1. So x square plus x plus 1. So you know it is x square 2 into x into half 1 by 4 plus 3 by 4. So this is x plus half whole square plus 3 by 4. So sum of two positive terms. So it is always positive for all values of x. Now we consider this one. X square plus x plus 1 lesser than equals to 1. So x square plus x lesser than equals to 0. So this is 2 and this is 1. So here x into x plus 1 greater than equals to 0, and here x into x plus 1 lesser than equals to 0. X into x plus 1 lesser than equals to 0. So this is possible only when x into x plus 1 equals to 0. So x greater than equals to y and y greater than equals to x. So we are getting x equals to y. So you are getting x equals to 0 and minus 1. Now we are getting two values of x. Most of the students write that we are getting 0 and minus 1. 0 and minus 1. They write that number of solutions 2. Mind it, 0 and 1 we are getting two values of x. 0 and minus 1. So they write two solutions. But you know, solution must satisfy the given equation. So let us verify whether given equation is satisfied by 0 and minus 1. So if we put x equals to 0, so this is tan inverse 0 and this is sine inverse 1. So tan inverse 0 is 0, so 0 plus pi by 2 equals to pi by 2. So not satisfied. So 0 is not a solution. Now if we put x equals to minus 1, so this one is 0, so tan inverse 0, sine inverse. So minus 1 plus 1, so this is sine inverse 1. So it is again same, 0 plus pi by 2 equals to pi by 4, so not satisfied. So accordingly we are getting two values of x, but these values do not satisfy the equation because we have solved the equation by taking domain, not satisfying the given equation. So you put values of x to the given equation. If it is satisfied, then it is solution. So no value satisfied it. So no solution. Number of solution 0. So this is problem of JEE Main. Now problem number 6. In your book, in Art Sharma or any standard book, you may get this problem. Tan inverse this plus this equals to pi by 2. Then find the number of solutions. So look, exactly same ways we are getting 0 and minus 1. 0 and minus 1. Because we are considering domain and we have already solved up to this. Now if x equals to 0, so this is pi by 2. So pi by 2 equals to pi by 2 is satisfied. If it is minus 1, right hand side is pi by 2, so pi by 2 equals to pi by 2. It is also satisfied. So 0 and minus 1 are solutions. So how many solutions? 2. So answer will be 2. So mind it, if it is pi by 2, sometimes it is given in terms of pi by 2, then you are getting 2 solutions. But if it is pi by 4, no solution. You can also solve this equation using another technique, transferring sine inverse in terms of tan inverse. Then if you transfer one term to right hand side, pi by 2 minus tan inverse, it will be cot inverse, and taking same inverse circular function, you can also solve it. So today I have solved some interesting problem of inverse circular function of JEE Main. In the next class, I will solve more problems, interesting problem of JEE Main of the chapter inverse circular functions. So if you enjoy this video, you please share and subscribe my channel Mathematics Demystified. Thank you.